Okay, well, let's start things off. First off, I'd like to thank you all for taking the time to attend the presentation today. My name is Lance Zurich, and I am the product manager for the Fisher Technic Education Division over here at Studica. And as you can see, what we're going to do today is I'm going to provide you with an overview of Fisher Technic's line of pre-assembled industrial simulation and training models, including some of the latest models incorporating some new cutting-edge technology. So over the years, when we do these presentations, I would typically begin with a discussion of the importance of STEM education and talk about changes in the manufacturing environment, as well as the growing need for highly skilled workers in the modern workforce. But at this point, I think it's all been pretty well established just why this type of technology-focused education is so necessary. And because of that, I'm going to basically dispense with that part of the preamble and pretty much jump right into the discussion of what Fisher Technic is, and I'm going to show you each of the current models in the simulation family. Now, just to give you a bit of background, Fisher Technic simulation models have been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated systems. Now, the line that you're going to see consists of a series of pre-assembled small-scale models like the ones you see here on the table, which are essentially designed to replicate both in appearance and in function various automated robotic machines and systems that you would commonly find in a commercial manufacturing environment. Now, before we begin to look at each of these models, I'm going to provide you with just a little bit of background on what exactly Fisher Technic is. Now, Fisher Technic has been creating tools for teaching students of all ages about technology and how things work for well over 50 years. Actually, I believe at the end of this year, it's going to be 60 years, and it's all based around their unique building system. Now, what makes the building system so unique is that unlike a lot of the other popular construction systems that you'll see out there that are designed primarily to stack, the Fisher Technic system was created with more of an engineering mindset. With this being the case, the core building block in the system was designed so that it enables attachment from all six sides. And because of this, it allows for almost limitless design possibilities. And many of the parts that are in the system are designed to slide together and lock in place using a tongue and groove assembly method. And because they have hundreds of different, very specific parts available, it will help technical builders to address equally specific design needs, such as the machines we're going to be looking at. Now, the Fisher Technic system was created back in the 1960s, as I hinted before, by German inventor Arthur Fischer, who's noted for countless innovations used in the construction and the automotive industries. At the time of his death in 2016, Mr. Fisher held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Just to give you an idea, prior to creating Fisher Technic, Mr. Fisher was first noted as the inventor of synchronized flash photography. This was back in 1949. And just a few years later, he gained fame as the creator of the expanding nylon wall plug, which is, of course, used in conjunction with a screw or a bolt to help anchor heavy objects to walls. I'm pretty sure we've all used them at some point in our homes. His company, the Fisher Group, continues to employ thousands of workers all around the globe, producing many variations of fastening devices used in building constructions. And up until very recently, they also produce numerous components used in the automobile assembly process, as well as providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, once again, the focus of Fisher Technic building sets, and these are their main products, whether these are intended for the retail market or for the classroom use. They have a series of building sets that are basically designed on helping to foster an understanding of technology. Now, many of the products in this line that are offered by Fisher Technic for the education sector are what we would call subject-specific sets. And in this case, they focus on different STEM-related and technology-related topic areas, things like mechanics, pneumatics, robotics, renewable energy, and other such topics. Now, many of these sets will either include curriculum or they include detailed teaching and activity materials. And in the case of most of these, students are going to be asked to build a progression of models that they're going to experiment with. And these experiments will allow them to explore and understand, key aspects of the subject being studied. Now, that's what the main Fisher Technic line is about. Of course, what we're going to focus on today are the line of simulation models, and these are something much different. In this case, you're not going to be talking about kits that you have to assemble, but these are going to all be pre-assembled small-scale models, which again replicate in appearance and function various automated robotic machines and systems. Now, some of the models in the fischertechnik simulation line that you're going to see today include things like conveyor belts, punching machines, three-axis pick-and-place robotic arms, color sorting lines, and even a high bay warehouse system. Now, we're going ahead. Besides these individual models which focus on specific automated processes, fischertechnik also offers several variations of an integrated factory simulation model. And in the case of the simulation, of the factory simulation, it consists of four individual workstations. This will include a vacuum gripper robot, a high bay storage warehouse, a multi-processing station with oven, and a sorting line with color detection that are designed to all work together as one self-contained material cycle. And of course, we're going to take a look at these models in more detail during the presentation. Now, before we do that, I'm just going to very briefly outline some of the advantages of using fischertechnik's simulation solutions. First thing is fischertechnik simulation solutions will allow educators to offer engaging, hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this can be for understanding how automated systems work, or just for having a tangible physical system to observe and work with in a programming or PLC-focused learning environment. The models, once again, are designed to realistically replicate, both in appearance and in function, common automated systems that you'll find, things again such as conveyor belts, sorting machines, robotic arms, and much more. Now, because the models are compact and in most cases tabletop sized, they're not only ideal for use in the classroom or, of course, in office demonstrations, but they're also great for demonstrating software or other technology-based offerings, let's say in a trade show environment. The next aspect we want to talk about is quality. Each fischertechnik simulation model is a hand-assembled, high-quality, precise German-made product. Each model that we're going to be looking at is available in a 24-volt version designed specifically for industrial users, with select models also available in a 9-volt version for those not versed in the use of PLCs or not, let's say, focusing on the teaching of PLC programming. Now, in the case of the 24-volt versions, they're designed for use with industry standard PLCs, and it really doesn't matter whether you prefer, let's say, Allen Bradley controllers, if you prefer Siemens controllers, or if you use controllers from manufacturers like Honeywell, Mitsubishi, General Electric. Of course, the list can go on and on. But in most cases, you can use these 24-volt models with the PLC that you prefer. Likewise, just as you can use your choice of controller, you can also choose from your favorite programming language from the list that's shown here to control these models. Now, please note, though, that with the 24-volt versions of most of the models, and there will be a couple of exceptions, and I will be very specific about it, but in the case of many of these models we're going to be looking at, especially in the beginning of the presentation, there's no PLC included, and any and all programming and all programming guidance, as well as supplying the power supplies or other hardware and wiring and what have you, that's going to be the responsibility of the end user. So again, unless I'm specifically mentioning that there are other components that are included in there, please note that that's something you'd have to supply on your own. Of course, this shouldn't be an issue as, again, these models are designed specifically for industrial users or for those who are already teaching or exploring industrial processes, once again, involving PLC programming. Now, as I touched on before, there are also some 9-volt versions available of select models. And in the case of the 9-volt versions that are available, these will ship pre-wired to fischertechnik's own proprietary robotic controller, which, depending on which version you get, could either be the Robotics TXT controller or it could be the Robotics TXT 4.0 controller. And in the case of these controllers, each controller is pre-programmed either using fischertechnik's own RoboPro graphic programming software or in some cases Python. Now, in the case of these pre-programmed 9-volt models, the only additional component required will be one or more 120 volt power adapters. And when we discuss these, I'll mention if you need that, how many are needed, and what have you. We'll, of course, get into pricing. Now, if you're involved in demonstrating or exploring IoT, of course, a very important subject these days, the Internet of Things. Now, besides the fact that many end users have adapted some of the models that you were going to be looking at in this primary line of simulation and training models to use them for IoT purposes, fischertechnik itself now also offers a special IoT-focused version of the factory simulation, where it's designed specifically for exploring and understanding cloud-based control and what would often be referred to as Factory 4.0. And in the case of this IoT-based version or IoT-focused version of the model, it's designed to be both controlled and monitored from a special web-based dashboard. And of course, we're going to discuss this all in detail when we get to that one. And finally, fischertechnik simulation models are cost effective. Now, if you've had the opportunity to look into any of the other hardware-based industrial simulation options that are available in the marketplace, and of course there are several, you'll probably notice pretty quickly that the entry point for many of these products can easily start at 30, 40, $50,000 or even much more. On the other hand, fischertechnik simulation solutions have an entry point at just a fraction of that price. And again, they are compact, realistic, and high quality learning and demonstration tools. So on that note, we're going to look at each of the models which are currently available, and we're going to begin with a look at some of the more basic models, and we'll work our way up to the larger factory models, which again consist of several individual workstations designed to showcase an entire production cycle. We're going to start off with the classic line of fischertechnik simulation models, and our first model in the line is a basic conveyor belt. And this is essentially a transport belt with a length of 275 millimeters that's used to transport work pieces with a diameter of up to 23 millimeters, or excuse me, 29 millimeters. And you could, if you so chose, you could connect multiple conveyors to, create a longer path of transport if you desired. Components on this model will include an excess motor, a push-button limit switch, two photo transistors, and two LED light barriers. And I do mention these aspects because some educators like to know it. Dimensions of the model are approximately 14 by 10 by 4 inches. It has a weight of just about 2 pounds. It is available in a 24-volt version with a multi-pin connector, and in this case, it's 26 pins with a 2.54 millimeter grid, as you will see here. And again, this 24-volt version of the model, as well as many of the models we're going to be looking at, will require you to provide the PLC and the programming. Now, there is also a 9-volt version, which is connected to a pre-programmed robotics TXT controller, as you see here. And in this case, one 120-volt power adapter is required for operation. And I will mention that for this and for all of the models that we're going to be looking at today, the specs are also detailed on the products listing found on the Studica and the fischertechnik.biz websites. I would say that if you go to the fischertechnik.biz website, you will find a lot more of the documentation posted on there currently. And there is also a product brochure that we have that we can make available to you, and I will provide information on accessing that as well at the end of the presentation. Next model we're looking at is the punching machine with conveyor belt. And this is essentially, as you see, a variation on the conveyor belt we just looked at, except this time it has a machining station built onto it. Components on this model will include two excess motors, two push-button limit switches, two photo transistors, and two LED light barriers. The dimensions are approximately 15 by 12 by 7.5 inches. It has a weight of just about 3.5 pounds. Again, the 24-volt version has a 26-pin connector with a 2.54 millimeter grid as shown here, and the 9-volt version comes pre-wired to the robotics TXT controller and again requires the 120-volt power adapter for use. Now, the next model we're looking at is the indexed line with two machining stations. And what you have here is this is essentially a U-shaped conveyor line consisting of a milling and a drilling station, and it has 4 conveyor belt sections. Components on this model will include 8 excess motors, 4 push-button limit switches, 5 photo transistors, and 5 LED light barriers. It has dimensions of approximately 19 by 18 by 11 inches, and it has a weight of just about 8 pounds. Again, the 24-volt version has the 26-pin connector with a 2.54 millimeter grid for use with PLC, and the 9-volt version comes wired to the pre-programmed robotics TXT controller, and in this case, you're going to require two power adapters. Next up is a variation on the idea of a pick-and-place robot, which they call the 3D or three-axis robot. The three-axis robot has gripping forceps, which it uses to help it quickly and precisely position the workpieces it picks up in three-dimensional space. The degrees of freedom for this model are as follows. Axis 1 turns 180 degrees. Axis 2 can move forward or back 90 millimeters, and Axis 3 can raise or lower 150 millimeters. Components on this model include two excess motors, two encoder motors, and four push-button limit switches. The dimensions of the model are approximately 19 by 16 by 9 inches, and it has a weight of just about 6 pounds. Now, as with the other models we've looked at up till now, this is again available in the 24-volt version with the 26-pin connector and a 2.54 millimeter grid, all designed for the use with the PLC and the programming of your choice, or a 9-volt version, which again is wired to the pre-programmed robotics TXT controller, excuse me, and does require one 120-volt power adapter. Now, the next model we're looking at is the vacuum gripper robot. And starting at this point, we're going to get away from just looking at the slides and we're going to have some video. So what you're going to see in this video is the vacuum gripper, which is essentially a three-axis robotic model, somewhat similar to what we just looked at, except here it has a vacuum gripping device. Now, this model is also designed to precisely pick up and position workpieces in three-dimensional space. The model itself includes three encoder motors, three push-button limit switches, of course, the vacuum suction device, a compressor, and a solenoid valve. The dimensions for this model are approximately 9 by 19 by 15 inches. It has a weight of just about 7 pounds. The 24-volt version of this model, as well as all of the 24-volt models we are going to be looking at moving forward in the presentation, each have a relay board for motor polarity reversal and both a multi-pin connector. In this case, we're going to be talking about 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And again, this 24-volt version of the model, as with all of the 24-volt versions that we're going to be looking at in this next section, will require you to provide the PLC and the programming. We'll just let this play out for a minute. And I apologize that I am muting the music that goes along with this right now, but otherwise I just end up talking over it. And there we go. So the next thing we're going to be looking at is an automated high bay warehouse. And the model you're going to see here features a transfer station with a conveyor belt, along with a shelf stacking mechanism for storing and retrieving workpiece carrier trays, has 9 individual storage spots, and of course the trays and the workpieces. Now, components on this model include the 2 encoder motors, 2 mini motors, 4 push-button limit switches, 2 photo transistors, 2 LED light barriers, along with a selection of different colored workpieces and the carrier trays for each piece. Now, I always mention when I'm talking about this model that it seems to be quite the favorite among educators who are involved with teaching PLC programming. And the reason, at least the teachers that I've spoken with, the reason they like this model is because it gives students a lot of very specific, precise coding tasks they need to address. Things like, again, the precise movement of the picker arm as it picks up the different trays and it has to store them on the different shelves, different levels, etc. So this gives a lot to work with, so they like it for that reason. Dimensions for this model are approximately 19 by 28.5 by 15 inches, and it has a total weight of 18 pounds. Again, the 24-volt version has a relay board for motor polarity reversal, and the multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as the additional PCB terminals with push-in connections for all inputs and outputs. Again, you supply the PLC and the programming. There is also a 9-volt version available, and you will need the power adapter for that. The video got way ahead of me on that one. Sorry. The next model in the line is the multi-processing station with oven simulation. And what you're going to see here is a furnace simulation with a pneumatic sliding door. So essentially, there's a downstream processing station with a pneumatic transfer unit that includes a vacuum gripper, a cutter with a rotary table, and it also includes the conveyor belt, of course. Components on this model will include 4 mini motors, 6 push-button limit switches, 2 photo transistors, 2 LED light barriers, 4 solenoid valves, and a compressor. The dimensions for the model are approximately 20 by 14 by 12 inches, and it has a weight of about 11 pounds. Again, it's available in both a 24-volt version for use with the PLC of your choice, with once again a relay board for motor polarity reversal in both the multi-pin connector, again 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. And the 9-volt version in this case is connected to the 2 Robotics TXT controllers. So in this case, 2 120-volt power adapters are required for the operation. I will say that at least in the early grouping of videos, when you see these, you will of course see that they have the TXT controller for the sake of the video. When we get to the factory models, those will be pre-wired to the, or those are going to have the PLCs in use with those. And there we go, delivered. The next model in our progression is the sorting line with color detection. And the simulation you're going to see here features a system for detecting workpieces of different colors that sorts them via conveyor belt into 3 different storage bins. Components on the model include 2 mini motors, 5 phototransistors, 5 LED light barriers, 3 solenoid valves, a compressor, and an optical color sensor. The dimensions for the model are approximately 20 by 14 by 12 inches, and it has a weight of just about 10 pounds. Now as before, 24-volt version, of course, has the motor relay board for motor polarity reversal and both a multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And again, the end user needs to provide the PLC and the programming. And the 9-volt version, of course, comes pre-wired to a pre-programmed Robotics TXT controller. And in that case, one 120-volt power adapter is required for use. I'm just going to let this play out and sort up the parts, and we'll move along. Okay. So the next model is the factory simulation. In this case, it combines the last 4 models that we've just reviewed. So you combine the vacuum gripper robot, the automated high bay warehouse, the multi-processing station with the oven, and the sorting line with color detection, and it combines them all into one self-contained material cycle. So the cycle you're going to see in the video works like this. Work pieces are retrieved from the automated high bay warehouse where they've been stored, and they're retrieved using the vacuum gripper robot. They're then moved along to the multi-processing station with oven, and after the workpiece has been processed by that station, it's then sorted by color in the sorting line with color detection before again being moved by the vacuum gripper robot to the automated high bay warehouse once again for storage. Now, as we've already discussed the components of each of these individual models previously, I'm not going to belabor it by restating them here, but what I do want to discuss are the dimensions of this model as a whole. Now, as you see it here, as it combines 4 individual models into one work cycle, keep in mind that it does have a much larger footprint because, again, this will ship pre-assembled. So your total footprint for this model is 39 by 31 by 16 inches, and it has a total weight of between 43 and 46 pounds, depending on whether we're talking about the 24-volt version or the 9-volt version. Now, due to these dimensions, and this would apply to any of the factory variations we're going to be looking at today. So due to the dimensions on the factory models, please note that these models can only be shipped flat as freight on a pallet. They're not shipped by UPS or FedEx. These are all pallet shipments on a truck. And I also have to point out that with some of these models, when we get during the peak order period, and a lot of times we're talking about, summer closer to fall for schools, that, sometimes you can run into some high demand. So you have to anticipate a turnaround time of, sometimes a couple weeks for these to arrive in our warehouse for shipment. I see the note about the UL certified. These are made in Europe. So of course they have, I forget if it's the certification for those, but there is different certification. A few other things to note. Let's see. Nope, we're okay. We're good here. Now, before we move on to the next group of models, and I will clear up that the note on the certification. If you can shoot me an email, I will look into that and get you the specs on that after. And again, I will provide my email at the end of this presentation. Now, before we move on to the next group of models, as you see over here, I want to talk about the storage option that's available for users of the factory simulation we just looked at, or some of the factory models we're going to be looking at moving forward if you want to transport the models, or of course, even if you just need to store them when they're not in use. And this is the travel case. And in this case, the travel case consists of an aluminum case maker profile, and it has plastic plates and steel ball corners, as well as 4 steel tilt handles and angle protection corners. In the upper section of the case is partially lined with soft foam blocks in different heights, and this is to help cushion the model. And it also has 3 internal zipper pockets for storing cables and other accessories. The lower portion of the case is lined with hard foam, and it's designed essentially so that once the top of the travel case is removed, the model can remain in the bottom section of the case and remain fully functional. It has exterior dimensions of approximately 41 by 33 by 17 inches. It has a weight unloaded of about 53 pounds. And again, do note that even when using this travel case, as I mentioned before, you still want to ship these models flat as freight on a pallet at all times to protect them. Just mentioning that. Now, moving right along, the next group of models we're going to look at focus specifically on the area of IoT. And these are the Training Factory Industry 4.0 models. Now, this group of models was designed to help address how the recent changes in industrial production, which were all, of course, driven by digitization, have created a need for stronger networking and more relevant information on all production levels. Now, with this Industry 4.0 update of the existing factory simulation model we just looked at, what you'll see is that such digitization activities can be simulated, learned, and applied on a small scale before they're implemented on a larger scale. Now, as the following video provides a pretty nicely narrated overview of just how the factory works, I'm going to step back for a moment and allow you to watch and listen to the narrator. So here you go.
Fischertechnik Learning Factory 4.0 illustrates processes for a digitized smart factory, from delivering raw material to the finished product. Industry 4.0 applications can be tested and demonstrated using the simulation model that has already been set up. Digitization activities are simulated on a small scale and learned before they are used on a large scale. The training and simulation model demonstrates the process from the delivery, collection, and storing of the materials through the ordering and the manufacturing processes to delivering the finished product. The training factory industry is controlled by a PLC controller, a Raspberry Pi as IoT gateway, and a TXT controller. The PLC program controls the individual modules of the factory. The program is written in structured text. The PLC communicates via the standard OPC UA protocol with the Raspberry Pi, which acts as an IoT gateway to connect the factory to any cloud. The program on the Raspberry Pi is implemented in Node-RED. In Node-RED, there is an additional local dashboard available, which can be adapted to your own needs. The Raspberry Pi also communicates with the TXT controller via the standard MQTT protocol, which in turn enables access to the fischertechnik cloud. The program on the TXT controller is executed in CC++. The sensor image data are used and monitored in the fischertechnik cloud. The integrated WLAN router transmits factory process data to the cloud in real time. The data is presented on a web-based dashboard. 3 views are available: the customer view, supplier view, and production view. The views and data can be accessed using internet-enabled devices and can also be used remotely. The USB camera is controlled from the cloud and can view the entire factory. A sensor station measures air pressure, air quality, temperature, humidity, and brightness. The default process cycle begins with storing and identifying the material. Using RFID NFC technology ensures that the material can be digitally traced. The integrated NFC tag stores production data that can be read out via the RFID NFC module. The cloud displays the part's color and the ID number. The vacuum gripper places suction on the material and transports it safely to the high bay warehouse. The production view on the dashboard shows where the product is in the manufacturing process. The first-in, first-out principle applies to outsourcing. The goods that were stored first are also the first to be removed. Ordering material is triggered online on the dashboard. The desired product and the corresponding color are selected in the customer view and then placed in the shopping cart. Customer-specific production takes place in lot size 1. The production process is simulated in 2 steps. The suction gripper passes the material on from one step to the next. The material is transferred to the sorting system once production is complete. The sorting system receives the allocation command as soon as the color sorter detects the proper color. The material is sorted using pneumatic cylinders. The production data is written on the material at the end of the production process. The finished product will be provided for collection. Instructional material and the source code for the stored programs are available online. The fischertechnik Learning Factory 4.0 is ideally suited for education and training in vocational schools and companies, for research and teaching in colleges and universities, for development projects in IT departments, for production planners, and for demonstrating in-house software solutions at trade shows and other corporate events. The customized storage and transport case is a worthwhile add-on.
So just to summarize a few of the points made during the presentation, here are some of the topics which can be addressed with the fischertechnik Training Factory Industry 4.0. Of course, training and simulation on a realistic production model, in-depth learning through haptic comprehension, optical and sensory applications, digital traceability with NFC/RFID technology, customized production in lot size 1, integrated cloud connection and control via smart devices using and operating dashboards, web-based remote maintenance, the linking of production and materials planning data, connection of upstream and downstream logistics processes, and of course, for experts, the creation of your own programming using C, C++. Now, as you just saw, the model incorporates many features not found in the models that we discussed prior to that, most notably being the use of the cloud-based dashboard for monitoring and controlling the model. Some other examples would include the camera that's used for visually monitoring the factory function from the cloud-based dashboard, as well as the environmental sensor, which collects data on variables such as temperature, air quality, humidity, and air pressure. In regards to, there's of course the NFC chips that are in each workpiece that enable the position of each workpiece in the work cycle to be mapped. And in regards to the 24-volt version specifically, I should note that it is a bit of a hybrid in that while requiring a PLC for operation and control, that it also incorporates one fischertechnik's robotics TXT controller. Now, in the case of the TXT controller, it serves as the MQTT broker and interface to the fischertechnik cloud communication between the PLC and the TXT controller, and it's carried out using an IoT gateway via OPC UA. And of course, OPC UA is also known as OPC Unified Architecture, and it's pretty much a standard for exchanging data across different platforms. Now, in addition to the TXT controller that's used here, there's also an IoT gateway using Raspberry Pi with Node-RED, and this will allow the option for not only presenting and using data on a dashboard in the fischertechnik cloud, as you were seeing here, but also to be able to display data and calibrate the stations of the factory in a Node-RED dashboard that you would create yourself. Now, the model also incorporates newly developed 24-volt adapter boards to interface to the PLC, and these, of course, ship as part of the assembled training factory and are connected to the PLC via terminals. Now, among other things, this latest generation of adapter boards allows for the speed of the encoder motors to be controlled via PWM or pulse width modulation. They also have push-pull output stages for phototransistors and buttons. Now, unlike the previous 24-volt models we've discussed, this new 24-volt training factory Industry 4.0 does also include access to a sample program. The program in this case is created in structured text or ST format, and it's created based around a Siemens S7 1500 PLC. This programming is available for download on GitHub. Now, of course, the new training factory can also be controlled using other PLC models and brands. And once the end user makes some small adjustments to the sample programs, and in this case, the source code that you would use for this is also available for download from GitHub, and this is absolutely free and you can access this. Now, all of this information and much more is included in the 152-page PDF manual that you saw the gentleman looking at on his device. And if you'd like to download this, you can go directly to the fischertechnik website, or you can go to the fischertechnik.biz website that we maintain, and you should find this right in the product listing. If for any reason you have a problem accessing that, you can also email me, as Christy added my email to one of the chats. You can just email me, and I'm happy to provide that to you as well. I also do want to mention that as of the last year, there are also 2 additional versions of this model which are available, and we're going to discuss those in just a little bit when we talk about the pricing. Now, in the case of the 9-volt version of this model, the control is facilitated through the use of 6 robotics TXT 4.0 controllers. And again, in this case, all the programming is preloaded so that once the connections to the internet and the cloud-based dashboard are made, all of which are clearly outlined in the downloadable documentation PDF, which accompanies this model. Also, this is different, of course, than the other one, but it's also all available on the website, or you can email me for that. Once you have that, you should be able to get started pretty quickly. The 9-volt version will require the addition of 3 120-volt power adapters to power the daisy chain TXT controllers. And while it should go without stating, we have to, of course, say it. Whether you're talking about the 9-volt or the 24-volt versions, it is also required that the end user, of course, has the ability to access the internet, as well as a tablet or device for accessing the cloud-based dashboard. And just to finish things up, the dimensions for these models are approximately 39 by 31 by 16 inches each, and they have a weight of approximately 51 to 53 pounds, depending on which version you're talking about. And as with the factory simulation model we looked at before, we do recommend the optional travel case to help protect your model during travel or storage. And that essentially is a Training Factory Industry 4.0 model. Again, it's available in a 9-volt and a 24-volt version. Next up, we're going to discuss the quality control with AI model. And this model incorporates the cutting edge technology that is quickly becoming a part of our daily lives. The quality control with AI system model from fischertechnik is really ideal for visualizing this complex subject area in a hands-on manner, as it creates a sustainable learning experience by linking theory and practice. Processes can be sped up, fault rates and costs minimized, and fault evaluation can be standardized. Now, the fischertechnik sorting line that you see here comes with work pieces in 3 different colors, which you saw something similar in the previous models. But in this case, these work pieces are marked with 3 different processing characteristics, as well as various fault patterns. Now, what will happen is the work pieces get scanned by the camera, and they are classified with the use of the trained AI. Moving right along the conveyor. Now, depending on the color, the feature, and the fault pattern, the work pieces are then sorted by the artificial intelligence on the basis of their quality features. The AI used is realized with machine learning and TensorFlow, where an artificial neuronal network was trained with image data. Now, the learned AI is executed on the fischertechnik's TXT 4.0 controller, and the model's sequence control is implemented in the RoboPro coding programming environment and also in Python. Now, if you want to go a step further, you do have the option of generating your own AI applications, and in this case, the training is done in Python, for which a sample project is provided for explanation. And that's essentially the new quality control of AI model. It's ideal for training, simulation, and demonstration purposes, for education and research, and for the visualization of AI systems, machine learning, and neural networks. Currently, this model is a little bit of an anomaly because it is only available in a 9-volt version, although you will see a variation on this incorporated in one of the models we're going to be looking at moving ahead. In this case, the 9-volt version that you're looking at does use the fischertechnik Robotics TXT 4.0 controller, and so you will require a 120-volt power adapter for use with this model. Now, the next model we're going to look at was just released in the fall, and this is the Agile Production Simulation model, which is the very latest iteration of the factory model, this time not only incorporating IoT and state-of-the-art manufacturing processes, but also AI, and this time with a digital learning platform included as well. Now, the factory of the future is the subject of numerous research projects in science and industry. Forward-thinking companies who rely on automation, modularity, artificial intelligence, and agility to remain competitive. Well, in order to promote these topics in industry and research, students, apprentices, as well as employees require the corresponding know-how and awareness to enable them to deal with these complex issues. And this is where the learning concept of agile production simulation comes in. So what it does here is it simulates processes such as quality assurance using artificial intelligence. It incorporates the functioning of a driverless transport system, and it replicates automated processes on a small scale, from the goods receipt to modular production to quality assurance. The accompanying learning materials translate the hands-on simulated processes into future skills for both the students and the teachers. The digital twin of the model significantly intensifies the learning experience. Now, as we do not yet have a narrated video of this brand new model, I'm going to provide you with a quick overview, beginning with the module where incoming and outgoing goods are placed. And this is, of course, where the material flow of a workpiece really begins and ends. What happens here is the raw material is delivered at the goods receipt slot. It's positioned on the color sensor for quality control using the 6-axis robot with vacuum gripper, and this is unique to This model that you see a six-axis gripper robot, and then it's encoded on the NFC reader. The robot then places the workpiece on the automated guided vehicle, or AGV as we'll call it, for further transport. This module also contains the central control unit, Raspberry Pi unit, and as well as the environmental sensor, which measures the different environmental conditions in the factory, just like before. Now, there's also an integrated movable camera, which again can be swiveled in two axes and provides an insight into the entire factory via the fischertechnik cloud-based dashboard, which again we saw an example of in the previous video. Now, at the end of a work cycle, a finished workpiece is delivered at the goods dispatch by the AGV. So this is again where it begins and where it ends. Typically, if we were beginning, the next step for a workpiece after goods receipt is usually the high bay warehouse. So, although, because again, this is an agile production simulation, that could be changed if there was a need for doing so. But in any case, the high bay warehouse here consists of 9 slots for work pieces, somewhat like the one we saw before, but this one has a stacker crane and a vacuum gripper that picks up the work pieces from the AGV at the docking station and hands it over to the stacker crane for storage. So a little bit different than the previous version of the warehouse that you saw before. Now, in this case, the workpiece is placed into a workpiece carrier tray for storage, and retrieval is done according to the first in, first out principle. If we moved right along in order, the drilling station would be the next station that you would encounter. And the drilling station consists of a docking station, again for the AGV, the automated guided vehicle. So it can basically dock with this station. There's a vacuum gripper that places the workpiece from the vehicle onto a conveyor belt from where it is transported under the drilling head. The simulated drilling process takes place, then the workpiece is transported back by the gripper on the conveyor belt, and then it places it back onto the AGV. Next, you could go to the milling station. This consists of a docking station for the AGV and a vacuum gripper that places the workpiece onto a conveyor belt from where it is transported under the milling machine. Of course, there the milling of 2 pockets is simulated on the workpiece, and after this process is completed, the workpiece is placed back onto the conveyor belt and transported back to the gripper. And in this case, the gripper then places it back onto the automated guided vehicle. Now, what you will notice as I'm mentioning this is that there's a gripper arm on each of these substations. Also mentioning that each of these substations has PLCs wired to it. So we will talk about that in a little bit. Next up is the quality assurance with AI module, and in this case, a vacuum gripper places the workpiece on a conveyor belt. It's transported underneath the camera and scanned there, much like we saw in the previous section. The workpieces will come in 3 different colors, white, red, and blue, and again, they have 3 machining features, drilling, and milling, as well as various fault patterns that are included. And this all gets classified by the trained AI. Now, depending on the color, the feature, or the fault pattern, the workpieces are either then placed back onto the AGV as being acceptable okay pieces, or they're sent to a reject container as not okay or as defective. Now, just to give you a little more detail on the AGV transports these workpieces from one module to another. It's essentially a track-bound vehicle that follows the printed black tracks that are on the factory floor, and it uses ultrasonic sensors to detect obstacles that might be in its pathway. The vehicle has omni wheels, which allow it to move in all directions. 2 buttons and a photo transistor help the vehicle to dock to the individual factory modules. And the AGV receives its driving command from the central control unit, which is an industry standard VDE 5050, and it uses a fischertechnik rechargeable battery pack as its power supply. Now, when that rechargeable battery pack runs low, the AGV will navigate towards the charging station, where it is automatically charged with a charger with charge monitoring. The contacts on the bottom of the charging station connect with the AGV and the charging electronics. So some of the specifications, you have a 24-volt power supply with 11 amps. Central control is by the Raspberry Pi 4B. individual module control. So each of those individual workstations is controlled via an SPS Siemens S7 1200 PLC. There are also three fischertechnik Robotics TXT 4.0 controllers that are used for the sensors, the camera, and the cloud access, and the WEA module for quality assurance with AI, as well as for the automated guided vehicle. The AGV, and there's again a WLAN router for the WLAN network. Programs that you will find used on this will be SPS programs in structured text format, TypeScript for central control of the Raspberry Pi, Node-RED for communication between the SPS and TXT 4.0 controller, and TensorFlow for supervised learning and quality assurance with AI. Now, again, there is also a digital learning platform with a digital twin of the APS model. The reason for this is so that learning can be done with both the actual model as well as in a virtual method. Now, we're going to have more details on all of this and a video overview of the model as well, available in a separate presentation that we're doing. And I believe we're launching it at the end of next month, so you can watch for that. There will be we'll be posting about that very soon. So if you want to find out more details about the APS, because there's a lot we can talk about, and the reasoning for why this was created, and some expansion modules and things of that nature. So if you're interested in that, please watch out for the announcement of that webinar. As again, that will be happening probably towards the end of April. Of course, at this point, we should probably discuss how much these models cost. So we're going to take a quick review of each of the options I've discussed, along with the pricing for each. If we're talking about the conveyor belt, in the 24-volt version, you are looking at a cost of $359.95 each. Again, you have to provide your own PLC. The 9-volt version does include the TXT controller, pre-programmed as $518.95. The punching machine with conveyor belt in the 24-volt version is $464.95 per unit. In the 9-volt version with the TXT controller, it is $599.95. The indexed line with two machining stations in the 24-volt version, it is $1,199.95. In the 9-volt version with the two TXT controllers, it is $1,394.95. Excuse me. The 3-axis 3D robot 24-volt version, $1,094.95. The 9-volt version is $1,369.95, again with the TXT controller. The vacuum gripper robot, this is only available at this point in a 24-volt version, is $1,199.95. The automated high bay warehouse in the 24-volt version is $1,448.95. The 9-volt version with the TXT controller is $1,318.95. Multi-processing station with oven in the 24-volt version, it is $1,287.95. The 9-volt version is $1,474.95. Sorting line with color detection, the 24-volt variation for use with PLC, $1,126.95. The 9-volt version with the TXT controller is $1,128.95. There might be a $2 typo there somewhere, because I think they were the same. Factory simulation. The regular factory simulation, this is the non-IoT focused variation of the factory, currently only available in a 24-volt version. It is $5,299.95. Again, you have to provide the PLC and the programming with this one. On the other hand, the Training Factory Industry 4.0, this is available in both a 24-volt and a 9-volt version. This is the IoT-focused version of the factory. Again, if you get the 9-volt version, this comes pre-wired to the robotics TXT controllers, pre-programmed. You need the internet connection for this, but you can monitor and control the model from the web-based dashboard. The 24-volt version, of course, will require you to provide the PLC, but there is a sample program in structured text format designed for the Siemens S7 1500. In either case, the cost for these is $9,659.95 per model. But as they used to say, but wait, there's more. There is also a variation with the PLC connecting board and cabling. This is for the 24 volt version. So normally with any of these models, as most of you would probably know, if you got a model like this, you would have to do a certain amount of wiring from the model itself. And obviously there are connector board, there's some connectors there, but you have to do wiring from the model to the actual connection board for the PLC and as well as doing programming and what have you. So with this variation, you get everything up to the PLC connection board. You would still need to provide your own PLC, but it still includes the sample programming, what have you, the wiring, what have you. You're looking at a cost of $12,879.95. There is a third variation that does include the Siemens S7 1500 PLC. So essentially, this is pretty much as close as you're going to get to a 24 volt version that includes everything you're going to need. You, of course, still need to provide your tablet and your internet connection and what have you. But what you're looking at here is the model with all the wiring, the PLC connection board, the PLC itself, if you're an EDU customer, if you're an accredited school, educational institution in the United States, you can purchase this for $19,639.95. On the other hand, if you're a commercial user, you're looking at a cost of $20,124.95 per unit for this fully wired version. So again, if you just want the PLC connecting board, you're looking at $12,879.95. If you're looking at the version that includes the Siemens PLC S7 1500 for education, it's $19,639.95. For commercial customers, it is $20,124.95. Other items that I've discussed, the 120 volt power adapters that came up several times, those are $12.99 each, pretty affordable. The travel and storage case that is used for the factory simulation and the training factory industry 4.0 models. So those factories we've looked at here, the cost on that is $1,524.95 each. The quality control with AI model, the 9 volt version, which again is the only version currently available, is $2,249.95. The 24 volt version is actually not available at this time yet, even though it said late 2024. That didn't quite happen. There are still some problems with creating a purely 24 volt version of that. So that is not happening just yet. The Agile Production Simulation, which of course we just looked at the end of this presentation. This is a 24 volt variation only. So there's only the 24 volt version, and it again includes 5 Siemens S7 1200 PLCs. It includes 3 TXT 4.0 controllers, plus access to the digital twin. So this is going to come everything all together. This is each of those modules, as you see, has the PLC and the connectors with each segment. So all of that is included. You're looking at a total cost here of $28,174.95 for the factory. There is a storage case for the Agile Production Simulation. It is a two-tier case. Unlike the cases we looked at before, it has a lot of different areas for storing different things. And you're looking at a cost of $4,024.95. As you see, this model, the Agile Production Simulation, comes apart in different segments where each is on its own board section, which they kind of have a little tongue and groove thing there where they can fit together. So once again, that case, and we do highly recommend that, $4,024.95. So on this note, at this point, if there were any questions, this is where they would come up. Again, with the person who brought up the question about the UL certification, I believe it is CL certification because it is a European product. As far as the APS webinar that I mentioned, as Christy was kind enough to point out to me, it is going to be on April 29th. It's going to be posted very soon. You can also, of course, email Christy at christyl@studica.com for more info on that. But again, we're going to have the invitation for that available very soon. So on that note, if you would like to take the next step, and that could be if you'd like to request the full color brochure that is available right now, if you'd like to ask any questions of us directly, if you'd like to request a quote or speak with the dedicated educational representative for your state, simply call us. Number toll free is 888-561-7521. You can email us with general inquiries, quote requests, info@studica.com. And if you have any questions for me, if you'd like to ask me anything in particular, anything I went over today, anything about Fischer Technic whatsoever, lance.zurich, lance.zurek @studica.com. So on that note, thank you very much for sticking with us. I thank you for attending today's presentation, and we look forward to hearing from you soon. Take care.